Alright, this comes from 3.5 part 1 modified, and it's question number 10 in the homework, and it has to do with finding holes. So you can see a couple of these options say, oops, that was supposed to be an underline, talk about holes, is there a hole, right? So we've got this rational function, f of x equals x minus 9 over x squared minus 81. So let me write that down here. F of x equals x minus 9 for x squared minus 81. And notice if I go to factor that denominator, it's going to factor into a difference of two squares, x plus 9, x minus 9, with x minus 9 still in the numerator. So I can write this in its simplified form. If I cancel those two common factors, x minus 9, this gives me a simplified version, 1 over x plus 9. Okay? So here's the deal, and this is where it gets a little bit weird. The domain still takes into account both of these restrictive values. So the domain for the function would still go from negative infinity to negative 9, and then, this is going to bleed over, then from negative 9 to 9, and 9 to infinity. So in terms of the domain, it's still just that x can't equal 9 or negative 9. But in terms of the vertical asymptote, and then any holes, whatever factor is left over, that's what's going to produce your vertical asymptote. So because we still have that x plus 9 factor left in the denominator, the x value that would make that denominator equal to 9 is equal to 0 is a negative 9. So if x equals negative 9, then this denominator equals 0. That means we have a vertical asymptote of the equation x equals negative 9, so the vertical line. But then, I'm just choosing a different color. So then what do we do with this x minus 9 factor? So this factor that got canceled out and is no longer in the denominator in the simplified form, it still creates what's called a hole in our graph at x equals positive 9. Okay, so had this stuck around in our final simplified version, it would have created a second vertical asymptote at the equation x equals 9. Because it got canceled out, all we say is that there's a hole at x equals 9. And I'm going to do a really rough sketch here of what the graph looks like. But we've got our xy axis. Okay. So let's say out here is x equals negative 9. So there's a vertical asymptote at x equals negative 9. And if you look at your graph, graph it like this. So if you look at your graph, the rational function is going to kind of skate along the vertical asymptote, look like this. Okay. And again, this is a really rough graph. It's certainly not super precise. But what I want to illustrate is that there is what's called a hole at x equals positive 9. So where x equals positive 9, there's actually a hole in the function. So the function doesn't exist at x equals 9, right? So if you go in and try to evaluate f of 9, it does not exist. That's my abbreviation for does not exist. So there's no value. It's not like f of 9 equals 0 or 2 or anything like that. If you guys type this into your graphing calculator, if you put this original function into your y equals in the graphing calculator, test it out. So try using the trace function. Remember, you can use that trace function and pop in different x values to see what y equals. So put in like f of 0, for example, and you'll get some y value. And then try f of negative 9. And you know that's not going to exist because there's this vertical asymptote right here. But then if you also try f of positive 9, you also will see that the function doesn't exist there. Even though it looks on the screen like it's going through x equals 9, the function doesn't exist where x equals 9. There's no y value for that. So when you guys get to the homework, you would choose option B, vertical asymptote at x equals -9, and hole corresponding to x equals +9.